Alrighty. We are at the last stream I think I have for Global Hack Week, but certainly not the end of Global Hack Week. There's a couple things left. But let me go ahead and do a quick tech check. I know I'm going to get ads, but if you happen to be in chat, drop a hello. Tell me how your week has been. We're going to be going over how to use Git, especially if you're not familiar with it or you just want to double check on some things. We'll cover a number of different commands, and if you happen to be more familiar with it, I welcome you to tag in as always. Hello, hello. You have returned. You were not there at my previous stream. It was very lonely, but I had plenty of new people, so no worries. But good to see y'all. It seems like things are coming through. Who knows, because I always get ads on Twitch. It'd be like that. Give it another couple seconds while this ad plays. Oh, it's going to be a whole 40-second ad. Oh boy. Well, I'm going to have to hope that audio is working. In the meantime, any issues with seeing what I've got on the screen? It might be too small, in which case, please let me know so that way I can go ahead and zoom in. We'll go ahead and work on getting started because we've got a lot to cover. I don't think we're going to cover everything, but we will certainly do our best as always. If I get distracted, it's just because I am watching some weather stuff going on with friends in a very serious area. So I will try my best not to be distracted. I muted it, but I am a little bit obsessing about it. Be like that. All right, people are saying things look good and they're saying hello. Where's my mouse? There it is. Hello, welcome. Got some new people. Alrighty, so let's get started. So today we are really just going over Git commands. I thought about creating a project, realized honestly I can just use the project I was working on the other day as a way to showcase, like let's do some real life things. I don't have much to work on it. I already fixed the bugs, but we'll play around with it. So I did fix some readmes. Perfect. I love that you all are telling me that you can see because that really helps make sure that we can keep going. So, and of course my cat wishes to leave, as always. We'll see if she changes her mind. But in the meantime, if you don't have a GitHub, feel free to go ahead and make an account right now. Just because I will be using GitHub for this workshop. That said, there are other options out there like Bitbucket and GitLab. And for the most part, your experience will be the same. It's just a matter of if you choose to use the website's UI and UX that will determine some differences in how we might interact with it. This will be predominantly CLI, command line interface. Just because it's good to practice, good to have the most amount of control possible before you start playing with extensions and applications that are out there. But if you all have recommendations for extensions and applications that I should add, let me know. This might be very outdated just because this presentation has been given a variety of times at my event. And so I, don't know about what's out there because I use CLI. So it's fine. But yeah, I'll give people a minute or two, especially if people come trickling in. Make sure that they are, what are you staring at, child? There's nothing there, I promise. It's just a door. My cat has gone full pointer dog. I'm not sure why. There's nothing in the house, I promise. I see. She's given up. Excellent. Hey! That's awesome. I'm glad you got a positive experience. I know that CLI can be pretty intimidating, which is, again, why we're doing this. So my hope is to expose people to things that way they're a little less scared or at least can be a little more willing to try it out, knowing that with great power comes great responsibility, which is how I always refer to using Git. But props to you for that. I should also clarify that there's nothing wrong with using a GUI. Some people just, it's easier for them, it's less stressful, it works for them. If it ain't broke, don't fix it. And Shen Marie, I haven't seen you in a bit. Thanks so much for coming. And as always, you bring great references, which this book apparently was super helpful for them. Personally, I usually use, I think, the documentation, which I think is this book. So we might reference it a couple times throughout this presentation. But yeah, let's go ahead and get started then. Let me go ahead and drop that, this one, that registration link in case you haven't had a chance to go ahead and register. Feel free to do so. I know you might be in the middle of signing up for GitHub. That's okay. We'll keep going. Again, if you happen to fall behind, don't stress. You can always watch this recording on YouTube. I know that Twitch doesn't always have all the videos all the time and super available, but YouTube definitely does. So check out our YouTube channel if you find that you just need a little bit of extra time, want to pause the video, etc. Alrighty. So presuming that you have made a GitHub, there's also the Student Developer Pack. And the Student Developer Pack is available to students. And what it is GitHub has collaborated with, oh my God. Oh, congratulations. That's amazing. I have never actually played that, but I really want to. And it's a post-PhD game that I'm going to do. Because I always learned on my own. So I'm like, oh, I can finally devote time to it. But congratulations, that is a accomplishment, to say the least. My cat is still going bonkers. Let me go let her out before she wreaks havoc in my office, and then we'll keep going. Okay, Peanut. Hello, yes. Do you wish to go out? You're not trapped anymore. Your choice. No, you're not going out? Okay. Yes, maybe? Maybe I gotta do it. I gotta tell people how to use Git today. You're not helping. If you're gonna go, you gotta go. Okay. Okay. Thank you. My cat child is an eternal toddler. She has needs such as getting in and out of my office. Okay, back on track. So, Student Developer Pack, I was going to post that link as well in the chat. If you don't have the Student Developer Pack, I highly recommend you go ahead and try signing up. It does require you to give a picture of your student ID. If your student ID doesn't have an expiration date on it, you'll probably have to give a transcript screenshot. And that will basically move things along, particularly if things take a bit to authorize. It does happen. I'm always a victim of it because my ID does not have an expiration date, even though I'm an eternal student. But that will change in like a couple months. I'll be done. Oh, wow. Yeah. So coming back together, there's a couple things. So we're signing up for GitHub if you don't already have one, or your preferred Bitbucket, GitLab, etc. You're signing up for the Student Developer Pack if you don't have it. I believe what I was saying was that the Student Developer Pack has partnered with a number of different companies who want to offer you resources that you wouldn't normally get for free. So for example, one of those is MongoDB, where maybe you want some free credits to work with MongoDB Atlas, their online cloud database, or maybe you just want to, be certified as someone who worked with MongoDB, which GitHub, I think the Student Developer Pack does let you take the certification for free the first time. At the very least, the training is available to you, and there's plenty more than just that. You also get access to ChatGPT, or sorry, not ChatGPT. You can get your own version of that. It's so cheap. Copilot, though, is available on the Student Developer Pack, and depending on if you're still learning or if you want just to speed run some things, Copilot's been pretty useful, as you've seen in some of my streams. Not always the best. We do have to make sure it doesn't introduce bugs, but it is pretty nice if we already know what's going on or we want some starter projects. So that's just a quick preview of the Student Developer Pack. Now, my plan for today is that we're going to run through some of the basic GitHub commands, or the most frequent ones that you'll use, using a presentation that I give all the time at SunHacks, which is the event that I help out at. And we'll spend some time here to really go into any questions if they do pop up. But no pressure. I will do my best to be as explanatory as I can, recognizing some people may be joining after the stream has ended. So as I said, there are more than just GitHub out there. GitHub just lets you use Git. They're built on top of it. It lets you visualize all your projects and things. And frankly, Bitbucket and GitLab will let you do those too. There are extra features, of course, that each offers. It varies based on your needs, but the point is there are many ways to interact with Git in a way that lets you interact with your projects, whether it's on your laptop, to your desktop, to a friend's laptop, or plenty else. And then at the end, like I said, we will go through any extensions or apps that we might recommend for people who are getting started with Git, might be curious about doing things with a GUI or kind of melding that CLI GUI experience or just going straight GUI. I get it. I'm not judging. we'll talk over, like I said, the frequent things and get into easy to hard. And so you can see if you want to get a quick preview of what we'll be going over, most of what we'll be talking about today is going to be everything in the easy medium place of the Git side of things, the dark side, if you will. And if we have some time, we'll talk about some hard things. Some of these things I've actually run into while I was a student, or at least I was an undergraduate student, where some students just didn't know how to work with Git. And again, with great power comes great responsibility. And if you're not really aware of that, you can introduce some interesting issues. We hopefully will have time for that. I'm trying to simulate something like that, but we'll see if that happens. If not, we'll talk about it conceptually. But as always, if you find that I have said something wrong, please correct me. I am known to be wrong. If you have any questions because I'm not being clear about something, please feel free. And if you have any resources, as always, feel free to drop those in chat and share. Cool. So by this point, you should have registered, you should have checked in to the event, you should have gotten a GitHub, and you should have at least started the Student Developer Pack application. Quick water break. We don't take breaks anymore, or at least we're going to have a chock full hour and a half to 2 hour workshop where I actually will spend some time going through the Student Developer Pack because not everyone's familiar with it. I don't know if it's actually going to let me go through the application because I already have it as a student, but I do know that you can actually see all the requests that I've submitted because it renews every few years and I've been in school for a very long time. But the short version is you would pick based on your role in education. And I know that this is not the easiest to read, so let's go ahead and zoom in. And let's also maximize that so you can super duper see this. So depending on whether you are someone who's a school administrator, a student, which is going to be most of you, or a teacher, you have access to GitHub Education, which is, of course, the Student Developer Pack and a lot of other things. And as you can see, they give you a number of opportunities as a student, whether it's GitHub Pro or other partner offers, like I had mentioned with MongoDB. And if you become a campus expert like me, you might be able to get some training to help you develop a community. Now, to qualify for these student benefits, you have to have a GitHub account, be at least 13 years old, which means if you're very young and you just got into your teen years, you are now eligible. But you also have to be currently enrolled in a degree or diploma granting course from an educational institution. So as long as you're middle school, high school, college, you should be good. As long as you're within the age range, you're good. But in order to do that, you do need to provide documentation, which could be, again, your ID with an expiration date, your transcript, or basically something to say that you are in a class for this semester in a school. Now, I typically use Chrome, but as you can see, they have a link for a supported browser. And there's some other information that you just need to make sure matches up with what you're offering. Your academic email address must be on your GitHub account. I have played with this and I have ruined things where I have been like, oh, let me just remove my, email because it's not needed because I want to have a different priority email. And then I grossly removed all of my GitHub developer pack stuff that I was like, oh no, this is bad. Yeah. So you do need two-factor authentication. I do use this. It's very nice. And then there's just some extra stuff that would just help you be a little more visible if you want. But the main things are, just be prepared. So you can see that if this would let me, it'll ask you to fill in the name of your school, and then eventually it will ask you to submit some form of identification, again, ID, transcript, etc. In my case, my school does not have an expiration date, so I often have to give extra verification because my email will never be deleted or something like that, even though I may not have access to it anymore. Go figure. Some schools vary, but the point is you may run into some issues, but that's okay. Usually it just takes an extra week and a half, and that's not really a big deal. It may impact you, which is why we encourage you to do this before the next Global Hack Week, so that way it's already processed and ready to go, particularly as you join the next Global Hack Week next month, which is Career Week. So as we jump into all of those things, highly recommend that you take the time to do it now, or if you're watching this later, do it when you're watching it. As far as getting things to work, I do know that some people have some issues sometimes. For example, if you're getting the MongoDB credit, there are instructions to ensure that you get the credit to your account. And I have had a few people stumped being like, why don't I see the credit? And it's because they never actually put the code in because they didn't realize they needed to get a code. So some of the things that are offered with the partners do require codes for you to get the credits or whatever other access you might need. Sometimes it's that you need to sign into that partner with GitHub, in which case it'll automatically link things up and you're good to go. Just never change your email because then it will break the login. Don't ask me how I know. I found out the really hard way and I spent like a month trying to fix it and it was horrible. I think it actually impacted a global hack week once. And then I spent the next 2 days debugging and roping in some full-timer friends, and it was not pretty. So just make sure your email is properly connected and all that stuff. But yeah, and as far as other information regarding the developer pack, I'm trying to think if there's any other like stopping points. Copilot sometimes just takes a bit to process. As long as you have the student developer pack approved, then you just need to like re-sign in through Visual Studio Code or IntelliJ or whatever it is you're using to make sure that it actually connects with the correct GitHub name to actually set up Copilot. I had a few issues. It just took me signing out and signing back in to fix it. I'm hoping that will apply, but I do know that at least the Discord, the MLH Discord, you can definitely drop in, submit a ticket if you're having issues. And if you have a local campus expert at your university, which you will find out once you join the Student Developer Pack, or your school, as a representative, you'll be able to actually ask them and maybe reach out to them to see if they might be able to provide you some extra tips or answer some questions for you to make sure that you get what you need. So campus experts are there to help. They're there to build a community. Highly recommend interacting with them once you find out who is local to you. If not, if you don't have one local to you or you're not sure because you don't have one at your school, I do know that the campus experts website, which you will have access to once you have the education pack, will show you like the world map of where everyone is or what place they're supporting, and you can probably find someone in your location nearby or see if they're hosting something that you might be able to attend. Okay. Stuff about the Student Developer Pack, basically done. Let me just double check really quick. Yeah. So another thing to be aware of with the Student Developer Pack that I completely forgot because I don't always do this. Depending on your school and affiliation, it may ask to share your location. And if you're doing this from home, it means it may not verify properly. So if you are doing this right now because you're at home and you're not at your school campus and it fails, try doing it again when you're at your university, high school, etc., nearby enough to just verify it. I get why it is a little inconvenient, but it's so worth having the pack. I truly promise you, it's not just because I'm a campus expert. It's not just because I'm giving this workshop. It's because I use the stuff in the GitHub developer pack. I have friends who are like, hey, you're still a student. Can I use your stuff? And I'm like, no, it's for me. Let me use it while I'm still a student. I love all the stuff, and we're always adding new partners, and it's always exciting to see. Like, I think a very recent partner was Codex. So if you want more tutorials that are in like a gamified version, I actually have a couple friends who work at Codex now and are making the curriculum. So it's really nice to see. Okay, moving on, let's talk about Git specifically. And we're going to jump to a fun little slideshow. So this is a very, very old version of our Git presentation. Not much has changed because Git doesn't really change. It does add a few new features and functionality, but most of this is not going to change. So let's get started. If you have no idea what I've been mentioning as far as GitHub or Git, this is the chance to tune in and pay attention, where Git specifically is a form of version control. And one example of version control is Google Drive and Dropbox, where as you edit things, as you upload files, you get new versions or version history, which is very nice when you goof and you're like, what happened? And it was 3 files ago, or it was 3 edits ago, or somebody else on the team edited something and you're like, you messed it up. All these things can be done with Git, but slightly removed, where version control for code allows you to track every modification to the code as long as you take note, let's say. where it's absolutely possible to go back in time comparing earlier versions of the code to help fix an issue. And generally, there's minimal interruption to your team. Although, if you don't know what you're doing and you push things, sometimes there's other issues, and that's a different problem. But we're not getting into that. And so, as far as what that means, coming back to that Google Drive Dropbox synonym or example, it does mean that this isn't really live coding. There's plenty of stuff for that, which, again, if you have the Student Developer Pack, you will get access to a free instance of Code Spaces, which lets you load up a bunch of stuff, share code with folks, and is pretty nice. But Code Spaces will also let you integrate with Git, which is very nice these days. Back when I was first giving these, we didn't have Code Spaces. Oh, I think that just dated me. Happens at least once every Global Hack Week at this point. It's okay. I'm graduating soon. It's fine. But yeah, so version control, super duper helpful, especially as you're getting started coding, especially as you're trying new things, especially as you're hacking. Let's say you hack, you're at a hackathon, you have a new project, you're trying out this tutorial code and it works, and you're like, okay, let me hit save, like in a video game, and just save my progress here, and then go on and do something else to fix it. And if it breaks, I can always go back to my old save. Now, if you use, say, Word or LibreOffice or whatever your preferred word processor is that is not Google Drive or Dropbox, a little hard to go back in the saves. It just keeps saving on top of it, and it never actually shows you the history, unless you have like revisions on, but it's not the same. Git, again, lets you do some of that magical time machine aspect to you at your editing. Now, we're going to talk about 3 key concepts today regarding what you should kind of know about what Git is doing by mastering the main concepts. You can tell that I wrote this slide, these slides, because there's so many puns in them, and I had too much fun with them, which is why I keep bringing this presentation back. But we'll first talk about commits. I remember I had just mentioned about saving something. About when you are in a video game, you're right before the boss, or you just did something and you want to hit save before you're like, I'm going to die a lot. I should make sure that I can come back to before, just in case I need to prepare some extra stuff, and be prepared. And the best way to view a commit is like those saves that you do in a video game, where a commit is a timestamp of your work in a project. And the way that this works is normally when you make a new save, you might be able to name it something, or it has a very specific tag to it. In the case of coding and committing, you're going to label the commit with a message describing what's going on. So this great graphic here, designed by a very old Sunhacks director of design, gave the idea that you're working with a couple files, you'll bundle them in a little bucket, and in order to seal or save it, you'll have a commit message to tie it all together. So the way that you might make the commit is where you're choosing what goes into it, which is mind-blowing when it comes from video games, because it's like, I can choose to save parts of my game, what? Or I can choose to save parts of my document. With Git, you can choose to change some of your files instead of the whole project, which can be nice if you're like, ooh, we don't want that broken file anywhere near anybody else, anytime, anywhere, because that is just not done. However, or whatever the reason is, the point is, once you've made changes to your project, you're going to add those file names to your commit. So think of a commit as like a box, and it has 2 components to it. One, which has a one-to-many relationship, where you'll have a number of files, or even just one, and then you have your one commit message to tie it all together. So a good practice with commit messages is to just ensure that you have a descriptive message that isn't too long. Now, you'll notice at a hackathon, though, that commit messages kind of go off the wall, just because once you get to like that 2, 3, 4 a.m. time frame, you stop caring about being good about your commits. But if you're doing a side project on your own, I highly recommend you practice writing good commit messages, where if you went back to it, you're like, I updated the CS. Okay, well, surely that was about my index file or my app file or my other file, or I could have instead said like updated maybe app CSS. Just a little bit of extra detail goes a really long way, that now if I went back to those commits, I could say, this is the commit I need. Because if I put updated CSS every time I made the commit, and I had maybe many edits that I was saving over time, that would get really confusing if I ever needed to go back in time, because then I'm like, which update CSS do I need? Oh no, that's hard to think about. So Coming back to what this looks like from the command line. You can see it on the bottom of this slideshow where we've made changes, we've hit Command S or Control S to our file, and now we're going to add those changes, specifically what files changed that we want to include them. Please note, though, that you can't add specific lines, despite my metaphor earlier. You can add files or even whole folders, depending on what you're doing. Just, be mindful of what you're adding. Choose carefully, let's say. You're going to add those changes, which is a great way to remember you're saying git add and then whatever your file names are. And again, you're going to wrap it in a commit message. So you're going to say git commit. And if you're ready to write the message in the follow-up line, which encourages you to keep short commit messages that are still descriptive, you put a -m. And right after that, that tag of -m will tell you this is what my message is going to be or what I'm wrapping the commit in. Again, in our case, we're saying updated CSS, which if it was just a bare bones, CSS, HTML, JavaScript, it could be like, a little fix here, little things there, like change the color. It could be more descriptive, but we're being generic for the case of this example. Now, the next concept to think about is branches. The way to understand a branch is to know that it's a series of commits. You can think of it as the story, history of your project, or even your timeline, if you will. But another way to think about branches is to think about it being actually a giant tree. Now, if you're familiar with Git and GitHub, you'll actually be able to visualize your commits and see things over time. And if you're ever bored, especially because it's open source week, go to an open source project and see if you can't see the history of commits and branches in this project. This is, I think, most easy when you have edit access to this repository, like to the settings or something like that. But if you look at maybe a student project, such as like your course project where you're working with a group, take a look at the end of the semester and see how far you've come and what your tree looks like at the end, particularly if you've been committing regularly, making branches for new features, and just practicing good Git process. We'll get more into that after this presentation. All right, so let's say I have a series of commits. And depending on how you read things, how you prefer to visualize things, the point is you're going to have whatever is on the newest part of it, your newest commit, and whatever is on your oldest side, which will be your oldest commit. Depending on your orientation, direction, etc., this will determine how you interpret your tree. Generally, for me, I look at oldest is on the bottom and newest is on the top, or oldest is on the right and oldest is on the left and newest is on the right, where I'm looking at it as if I'm reading a book. Now, right off the bat, we're like, well, this isn't really a branch. This is like a main tree, which, congrats, your main branch is, in fact, your main tree trunk to your project, where things started. However, what happens when you have more than one branch? Does it really look like a tree? And we'll get into that a little bit once we better understand what a repo is. Which, as you can see right now, this is kind of what your tree will look like as you look at the colored dots. But a repo is short for repository. A repository is just a fancy way of saying your project folder. So when you're working inside one repo or one repository, you're generally also working on a specific branch at a time. It could be your main branch, it could be a feature branch, it could be a sprint branch. There's a lot of different ways to make branches and designate them as developer sections and a variety of other things. And we'll get into why again a little later. But a repo is a collection of all your branches as well as all of your project folders. What sets it apart, though, is that a repo means that Git has been initialized in it, versus a normal project folder that has nothing to do with Git is just a project folder. There's no way you're going to track anything if Git isn't included in the folder. So another way to consider it is your highest level project folder. You may have seen in my file history that I have a top level folder called repositories, and then I have all of my projects in different folders. And depending on what I'm working with, I'm in one of those project folders. It's not that the repositories folder itself is a repo, but the repositories folders in my computer is all of my project repos, which are usually Git projects. And in this case, we have a bare bones source with index HTML and style CSS. And we also have this new file .gitignore. Now, as you get into more complex projects, or if you've been familiar with working with JavaScript and Node modules, you'll probably go, wow, I really don't want to commit thousands of files when I haven't changed it. But Git is saying, I have changed thousands of files. That doesn't make sense. I only imported a few libraries with their dependencies. the git ignore file is really helpful to filter out the things that should not be ever pushed to the internet. Another way to think about this is if you have secret API keys. Let's say outside the source folder, I had a .env file or .env, and that had all of my API keys for whatever my project was. I definitely don't want that being published on the internet. And there's a lot of nice things that will tell me or email me saying, hey, your key is public. Have you considered getting rid of it? Yeah. So if you have a git ignore, you can automatically add, hey, don't push any .env files to my repository. I don't want to track it. I don't want anyone seeing it. And the git ignore will filter that out for you as long as you set it before you push things. And I haven't clarified what push is, but yeah. So .git ignore versus .env. A .git ignore is related to the Git instance or Git process. So everything that makes Git happen in that project folder includes git ignore. You'll also, if you happen to do a list of the pieces, which actually I can show you in a moment, you'll be able to see probably a .git folder. And you'll probably wonder, like, well, what's in there? Do I need it? Well, that's everything that makes Git do what it does to track your history over time. But a .env file is oftentimes used to hide things like variables, API keys, or things that generally shouldn't be available to anyone except the except the developer, especially if maybe you have your own keys that you want to use, because APIs are expensive. So let me very quickly show you what I mean. Okay, so currently I'm in a Git repository. And you can see, because it says main over here, I'm using a Git bash. And if I went to say list everything, will it do the thing? Oh, there we go. Okay, so if we look at my files for this Git repository project that I did a couple days ago, I did it yesterday. It's not a couple days ago, yesterday. Oh my goodness. You'll see these highlighted folders. You have a .git ignore, which is a file, and you have a .git folder. If I were to make a new folder outside of this project in my repositories directory, which I've made, of course, there will not be a .git folder unless I've goofed and accidentally initialized my repositories but never set it up. That's a possibility. But it has all of my files here. And then it has my, like, oh, I can go up folders or whatever. So if, let's say, I cat.git ignore. Oh my goodness, it is struggle busting today. So there's a lot of things in this, and I'm not showing the file just because I'm really lazy, but you can see that environments.env.venv, environment folder, vn folder, capitalized n folder, env.back, vn.back. Wow, that's a lot of things to like ignore. Because if I pushed any of these things, that's going to bloat my Git in a way that's not compatible with other people, or again, leak secrets on the internet. Not ideal. And so again, I'm on this main branch. And for this project archive notifier, we did it yesterday, watch the previous stream. But the point is, there's lots of different things here that basically exclude what files we don't want on the internet. This can be project files. It can be the what's the Mac version? It's like .macOS like folder or something or other, .macOSX or something. Like no one needs that on GitHub because like you don't even need it, frankly. It's just permissions. Versus the .env itself, I don't have one here, but I've used it in a couple other projects where, again, I would put my API keys. Yeah, so very long tangent, but worthwhile doing that because that was important. Okay, so starting a project. I think I was going to come back to pushing something. Yes, that's right, because we're going to do... It's been a while since I've given this presentation like this. I like speed ran it for Sunhacks this year, so I was like, yes, concepts. But we're actually like spending the time to do it because we're not running out of time. So yeah. Okay, so when you make a brand new repository, which I can show you super fast, if I can find my window. Oh, it's because I'm... Duh. Okay. So let's go to GitHub. And let's go ahead and make a new repository. I'm not actually going to make one, but I want to show you what it looks like. So when I'm creating a new repository, I could use a template. I don't need to / want to. I don't think I actually ever will unless I'm told to do so. I have many projects that I'm on, so I would choose myself as an owner. I would give it a name, description. As you can see, GitHub gives us fun little ideas, although they're not really explainable, whatever. But you have all these extra options where you can initialize the repository with a README, add the git ignore that we were talking about, and choose a potentially open source or restricted license, which super good to know, especially for Open Source Week, but we're going to ignore those for now. We're not initializing any of that stuff. We will start with a brand new empty repository. And what that does is that if you are starting with a brand new empty repository, GitHub has a really neat feature where they have the command line instructions you would need to set up a local or on your laptop or on your desktop instance of a project repository. And all you have to do is connect your cloud version or your GitHub version to your laptop version, which is local. So 2 things to learn from this. 1, you have a local instance. 2, you have a remote instance. Your local instance is going to be what you directly interact with on your laptop, on your desktop, your iPad if you're an iPad coder or tablet coder, however it is that you interact with a physical device. But anything remote is going to be anytime you work with GitHub's UI, or just you want to interact with what code is in your cloud or remote instance of it. In this instance, it's saying, hey, create a README file. Whoops-a-daisy, got ahead of myself. You're going to initialize Git in it to give us that .git folder. Then we're going to add the README as we would because we've created one. It's an empty file there. But we need to make sure that we bundle it in a commit. And the most common first thing to do when you set up a repository is say git commit -m first commit or initial commit. Depends on the person, depends on the repo, etc. The next thing you have to do that I always forget to do is you have to add your origin. And what that means is you need to draw the line from your local instance that you're currently setting up to your remote instance that you've already created a repository for, you just didn't populate it with anything. So once you create that link, you're using git remote add origin, and then whatever your user is, and then whatever the repository is that you're connecting to. Notably, if you don't have the permissions to push there, you're not going to be able to connect to it, and it's going to freak out when you push. So we've drawn the line and we've said, you're connected. We've created the pipeline where things are going to happen. But what's this last line, git push -u origin master? This should actually be changed to main because, again, this is a very old presentation. But something that's going on here is we're saying push. And if you're not familiar with this terminology, it's going to be, whoops, I forgot to take that off. If you're pushing something up, and that's kind of how you should remember, is that when you are working on your local instance, your laptop, your desktop, your tablet, however you code that's on a physical device, you are pushing your changes up to the remote instance. And of course, the reverse is that you would pull your changes or somebody else's changes on the remote repository down to your local instance. There are many ways that you can interpret that or look into different ways of understanding it, but the way that I've always understood it is local is in front of me. Remote is basically cloud. Not quite the same thing, but kinda. And so as long as I'm pushing things up, that means the cloud will have it. And as long as I'm pulling things down, then I will have it. So continuing on, this actually walks you through creating a new repository, and we'll get a chance to see what this looks like. Now, what I did was that I said, hey, we're not going to create any of the files, but this one already has. This example says, hey, do you already have a repository created? Maybe it even has code in it already. In which case, you're going to clone with HTTPS or SSH, or I think there's another thing you can do. Again, this is a little bit outdated. The screenshot is from an older version of GitHub. There are new things now. But the point is, what does it mean to go ahead and say, well, I already have a repository and I want to clone it? Now, when you hear the word clone, you probably think, okay, well, I'm going to copy it. If we were to do this on command line, it would just be git clone and then whatever the project URL is. And GitHub is nice enough to give us a copy button, which will let us just paste it into our terminal. Cool. So I already told you about pushing and pulling and how it's up versus down. But the way that this works with more than one person now is that whenever I push things up to the remote instance, you maybe on your side can pull my changes down to your instance. If we were on a team together, you would be able to access my changes so long as I push them up to remote. And this is something that catches people who are brand new to GitHub. Chances are they're like, I've pushed my changes, but maybe they forgot to hit push. All they did was wrap things in a commit message, which means they've created all these nodules, but they never actually followed through with pushing those nodules up, those saves in time, so to speak. Vice versa, it could be that you forgot to pull the changes from your teammate or the things that happened in the remote instance, in which case you might be behind and you don't have whatever's on top here. And that will introduce a later issue called merge conflicts, which makes for a nasty time. Easily among the more scary things that you have to deal with, but for the most part, as long as you're working on different files, you shouldn't have merge conflicts. GitHub, or at least Git, does tend to naturally kind of manage them for you. Okay, so yeah, as you can see, I was very exuberant about saying you need to make sure that you share your code with your teammates, that sending a zip is in the past, sending a flash drive is in the past, using Git is where it's at. And it has been for a really long time. So as long as you make sure that your changes are always pushed and anyone else's changes are always pulled, you generally should have a pretty functional team. And vice versa, again, we are pulling it. So we're not going to talk about this fun fact yet because we are going to get into it after this presentation. But I'll tell you more about how these things are put together because there's some neat aspects to it. So let me introduce some more information for you to fill your already full brain, and tell you more about some keywords that you should probably know as you start to work with Git, where in order to add files, it's a process called staging your changes. So think of it like you are preparing something. You haven't fully committed, but you are ready to start that process. In order to start that process, you need to identify what it is that you are going to be bundling up to send to your remote instance. And so there are a couple different options of doing this, and you'll find that most people say git add dot or git add period, which I always say don't do that. That's dangerous, because what happens if you didn't set up your git ignore? Congratulations, all those files you didn't want to add are going to be added, and it's going to be gross, because then you need to go back in time and recommit and refix and everything, and it's like, no. Instead, it's better to manually choose your files or your folders that you're going to be committing and bundling together. So you've staged your changes because you've selected the correct files that you want to push, because maybe you've done 2 features and you're like, these are 2 separate commits, because that is smarter organization-wise for your future self to go, hey, past me did not do a good job on feature A, but at least feature A was 1 commit, instead of it being a commit with both feature A and B. For example, has happened, can confirm, it's a miserable time. Don't do that. As said, industry varies. Everybody has a different push process or commit Everyone's different. Just try and commit at least once a day. When you're working on code progressively, try and commit once a day. Just build a better habit. Okay, so we've staged our changes. We've selected the files. Now we want to save our changes or bundle them up with a commit message. We're wrapping it around. Now, you notice that I added the -m tag and then put in quotations whatever my code was doing. But you'll also see that if you just put git commit, it will open a Vim editor. And the most asked question on Stack Overflow for a number of years, I don't know that it's changed, I don't think it has, is that people don't know how to exit Vim. And I will tell you right now, if you learn nothing else from this workshop, please know that the way to exit Vim is to hit escape to make sure you're in the proper command side of things, hit colon, and then hit Q, not uppercase, just lowercase q, and then hit enter. And you're good. That's how you exit Vim. No changes will be saved, and that's okay, because clearly you should have just used git commit -m. But if you do like Vim, if you want to write a longer commit message, if you want to tag specific issues and do a couple other things, then consider using git commit, because you'll be able to have more control with your commit message, which means that, again, integration with GitHub, if you say, hey, commit issue number blah, 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 sometimes if you have it configured correctly, Git will automatically close the issue or tag the issue that the code is referencing, which is really nice for open source week when you're like, hey, this code is for this specific issue that was outlining blah, 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 and we did the testing for this specific issue. Or maybe it's that you want to address a specific task. That can also be available depending on if the project is using a Scrum board or whatever their setup is, which would automatically resolve the task once it's merged into the main branch. So fun facts, there's some automation processes behind the scenes depending on your commit message. Okay. And to close it all off, let's say you've hit stage, you've got your files, you've hit save, you're ready to move on, right? No, absolutely not. This is the annoying part of it because you're so used to just hitting Control S or Command S, or hitting save on your video game file, or it auto saves for you. Git is a manual process. So after you've hit save, technically it's saved, but only for you on your local instance. So you have to make sure that you send your changes to your remote instance so everyone else can have them. So git push. Just push your stuff up. There may be issues. We'll get into that later. But the point is, if you've committed, you're not finished. You must send your changes. So just use git push. To shorten it all up, I know that was a pretty busy slide. You should be adding your files, committing with a short descriptive message so future you knows what you goofed on when you come back in time, and then git push. An optional thing to add is your origin or branch name, depending on where you're trying to push from. I wouldn't stress about needing to know that part now, but it might be helpful in the future if you're working with a lot of branches or you're trying to do some fixing and rewriting some history. Okay. Now the scary part. I hate this part because everybody hates merge conflicts. Yes, as evidenced by someone who has finally reached level 3, you can get out of Vim. You are not trapped like other programmers. I love that. Okay, so merge conflicts. Let's come back to that idea about the main branch and how you can have multiple branches. As you see from the left side, we have a git merge occurring where there was a branch that separated and then came back together later in time. And generally merging is exactly what it sounds like. As long as there's differences in the code, it just gets slapped together and it says, great, no issues. The difference between the codes across these commits, there was no conflicting errors because based on time, if we look at this timeline, there was a commit on the bottom in the blue, another commit and then slightly lighter blue, a branch in orange, and then a commit in yellow. And when it all came together, there was nothing on this main branch to interfere with the yellow or orange dots before it finally merged in the final top node, which is honestly a very great day, which can be the case if, let's say, you and a friend are working on things, you push first, there's been no changes because your partner hasn't pushed yet. Or you both are working on completely different files and there's no intersection point whatsoever. That's a good time. But what happens if you're working on something at the same time as your teammate, or you're both working on the same file? And so now there's conflicts because now you're like, who actually deserves to be the right one that you push that is going to be the formal final choice? And then you start getting confused because you're like, what did work? What didn't work? I don't know. Who's right? Who's wrong? Oh no, what do I do? And so the short version is that there's conflicts whenever the code that you're pushing overwrites newer code, especially if your branch is behind for some reason, or the code that you're pulling down to your local instance overwrites your code. This is the most common time I come into this. I always pull down code and there's always conflicts in my code. And I'm like, why? Just stop touching my files. And I get that, but life isn't always like that, especially when people are working on a feature that might be in the same page or the same file that you're working in, which these days, I feel like that happens all the time. So maybe push first. I don't know. That's not a good idea. Don't actually do that. But handling merge conflicts, you can do it one of 2 ways, or 3 ways actually. You can choose which code goes through by using it in your editor. You can see this on the left side where there's the less than brackets and then head, and then whatever it is that's in there. Then you have some equal signs, and then you have whatever this commit hash is. So a quick way to see what's going on. This merge conflict occurred because I was pulling code down that conflicted with my stuff locally. So head is where I was currently at. Head was my code, my work. I hadn't made a commit yet. But let's say my partner had pushed stuff that, messed with my files and therefore caused a merge conflict. And that's what's going on here in this second part here, this bottom half of the conflict. There's a commit hash right there, which tells me, hey, this is whoever else, this is my partner's code, and he's goofing me up, but he's right because we did need to add the class that it was a header, whatever that may be. So at that point, I have a choice. I can choose to keep their code, or I can choose to keep my code. Depending on what's going on, maybe I need to choose both, especially if Git just kind of derped and didn't understand what was going on and said like, it's conflicting. And it's just because there was like a lot of lines deleted or something. The Git diff part is not exactly the cleanest and best, but it is quite efficient. It's just that when it fails, it fails. It fails pretty bad. So you'll see this as well in any GUI that you might use. There's often merge conflict helpers. Well, they'll find the code that has the conflicts. They'll show you which one is which. They'll show you what branches things are on. It's honestly pretty nice because then you also just have to be like, oh, just choose A or choose B, which is very nice, again, if you know which one it is that you need to keep. But I find that I never know which one I need to keep because I'm always like, what am I looking at? I don't get it. Like I made a commit and then there was merge conflicts. Now there's two commit, and I freak out and I'm like, just show me the code. Just let me go through and quietly fix things. To formally get rid of a conflict, if you're working in a file, by the way, and you're not using a GUI to manage it for you, is you do have to delete those brackets, equal signs, commit, etc. So you have to delete what's on line 8 where it says head, line 10 where there's the equal sign, and line 12 where it has the greater than equal sign and the commit hash. Depending on what's going on, I may also delete either line 9 or line 11, both, or neither. It just depends on the code itself. So another way to do that is to stash your changes. Basically, take all of your unstaged commit stuff that you're like, oh, I'm working on this and I'm working on that. Oh, I need to go pull code. It's going to conflict with my stuff. Let me go bundle all of that up and just shove it into a stack somewhere. And just shove it aside, go pull down the new things, and then unstash things, and then go find those commits. Because maybe I just don't want to deal with my changes. Or maybe my changes are worthless, and I'm like, dump. Let's just go start fresh. It's just easier to start fresh. In a hackathon, that happens a lot. Another thing you could do is reset your branch where you remove any of the changes that you've made that you're tracking. We'll talk more about that. Okay. So as I mentioned, there is a ton of different GUI tools to get you started if you're not friendly with CLIs. Git Bash, of course, being the CLI. There's Git Kraken, which is a great GUI, Git GUI, TortoiseGit, SmartGit, SourceTree, and plenty more. I think there's also like GitHub Desktop or something as well. Point is, there is no shortage of tools, so if one doesn't work for you, find a different one. You don't have to do what everybody else does, but I do highly recommend every so often, it doesn't hurt to practice the CLI stuff, just in case your GUI doesn't know what it's doing and creates a bigger mess than you wanted in the first place. So as far as taking control of your learning, as it turns out, Shen-Marie, I did in fact have your docs already in this, yay, but there's also a couple other things. And generally, you can just go and Google, how do I do a Git whatever it is, or here's my Git error, or go to GitHub or whatever. Even ask ChatGPT, knowing that you may not get the right answer. The point that you have to consider is that you really got to make sure that you read whatever the Stack Overflow is saying or whatever just double check everything before you do it, especially when you're doing a command you're not super confident in. Because if you don't do it, you could totally delete your history. So that's why I keep saying with great power comes great responsibility, because you can rewrite time. So if you don't know what you're doing, you could delete time, which is bad. And I've certainly seen that happen where some people are working with Git, they're not fully understanding what's going on, and they lose their entire history. That happened at Sunhacks. It was horrible. We had no idea how to get it back. We tried every trick in the book, even some things I'm going to mention today. And yeah, it ripped to that hacker and their project that they had to restart because that sucked. Cool. So we've gone through that presentation. I also should be checking stuff off. And we've gotten most of the concepts down, being that we're like, okay, we have some of the easy things that we'll use, which is what we already talked about. We talked about git clone, which is when we want to copy a repository and maintain the link to where we copied it from. This is the importance of doing a clone versus a download as zip. And I didn't clarify this, but when you're cloning things, you do maintain that git remote add origin bit. You don't have to set up the pipeline because it's already there when you download it. Super neat, super nice. But if you download things as a zip, so let's say instead of going git clone, you just say, hey, download as a zip from the UI, you've cut off that pipeline, which means you need to remake that pipeline if you want to. We talked about branching, where you can create new branches, but I didn't exactly show you how, and we'll talk about that. But we did go over pushing and pulling, as well as that's about it actually. We talked about pushing and pulling, where you push up to your remote repository and you pull down to your local instance. But we haven't talked about checking out things, branching, logs, configurations, or status. If you have just started getting used to Git, chances are you're going to need to use the config to set your email and name. And in setting your email and name, it might be that depending on the folder of your repository, you should probably use a different email. So for example, I have a couple different domains that I use for certain projects, just because I have emails that are associated with those specific projects. Because I'm part of a nonprofit, they gave me an email, which means that when I make commits to their work, I do have to use the nonprofit email I've been given. So I can locally configure my repository to only use the email that I need to. But maybe globally, I'm using a different email altogether, like my professional email, and so on and so forth. So let's actually look into log and status. Okay, so we're going to go ahead and do a git log. And you can see that I have some commit hashes here from when I've done some things. You can also see my commit messages right here. So if we go back in time, which is how this is, it gives you the most recent commit and it works our way back. And again, we're working with a project that I had worked on yesterday. But this is the version that I had made before this workshop, or before yesterday's workshop, as a prep file, just to make sure I'm like, does this even work? And then I was going to publish this, which this is public. So it says that it tells me who the author is and their email, which I configured this with, my git config. And then it tells me when it is I did things. It told me what the commit is. It told me what branches I'm currently on. It looks like I'm on main, and it's connected to the remote main branch, which is origin. And then you can see another commit I made where I was debugging on Mac. And so it looks like I added some things because I had to consider a Mac OS instance, because my laptop, the way that this works is operating system dependent. There we go. So really nice to know, like, hey, if I want to potentially git blame someone, for example, let's say I was debugging on Mac and I found a really big bug, and I would be like, well, who wrote that? Well, the answer is me. But I could go back in time and go, well, such and such user committed such and such message, which also affected such and such file, because I can go to these commit hashes and go pull diffs if I wanted to. So the commit hashes are pretty important. So let's go back to GitHub. You can see that these hashes are shortened, but you'll also notice there's a bit of a difference here on purpose. We'll get into that. Being that there's a different commit hash up here that I had just committed an hour ago. And you'll see that, hey, the most recent commit was actually yesterday. So what gives? Why is it that we can't tell what's going on in our log? Because, hey, we didn't actually update things to go pull from our main. And I did that on purpose. So log helps us figure out, like, what happened. We can use git blame if we wanted to. Let's go to git status. And I guarantee it will probably yell at me about something. Come on. Why can't I not type? Actually, why can't I type? Okay. Question mark? Okay. Is it though? I wasn't actually intended for this, but that's a good joke. Yeah, so we're using command line, like I said. Cool. So I'm going to do a git status, and it is not a bad idea to do this all the time. Interesting that I type. Okay. Weird that it didn't like that, but okay, go figure. So I type in git status, and it says you're on branch main. Your branch is up to date with origin/main. There's nothing to commit, and my working tree is clean. So what I could do is make an edit to my file. Let's go to main. I'm gonna zoom out a bit because I can't see. This is a comment to change the file. I'm gonna hit save, and I'm gonna run git status again. All right, now I'm getting screamed at. We love that. So when I ran git status, it said, hey, your branch is up to date still, but I have some changes that are not staged for commit, which is where those keywords come back. It means that I haven't added anything to wrap into a commit message that I can then go pull. And so maybe I want to, in which case I would say, oh, git add main.py, because we specify files. If you get nothing out of this, hopefully it's that. And then I would go commit whatever, but I don't actually want to commit those changes. Let's say I made a mistake and I'm like, I have done this all wrong. We need to go back to the beginning. So let's go introduce a really quick, medium, if you will. Git reset. Okay, so it says unstaged changes after reset. Does it still have my commit? Yes. Okay, what if I say git status? I didn't actually add this, so let me go double do that. Add main.py. So I've staged my file. We're going to see a different color. And so now it's saying, hey, you've staged a file. The moment I make another change, this is another change, this is no longer staged for commits. I had to hit save. I do git status, and voila. It's telling you, hey, your main.py is staged, but there's some new changes. Do you want to add those? In which case, yes, I do. Git add main.py. Okay, git status again, because we want to know what's going on, especially, let's say, it's a massive project and we have 50 files. Okay, now, it says that I could say git restore staged to unstage. Well, what does git reset do? Git status. Okay, so git reset and git restore would allow us to remove things to not be staged for commit. Not that bad. But what if we want to reset things to the beginning? We're like, undo these changes. We don't want this change to exist anymore because we goofed so hard, right? Let's see if this will give us something different. So we have git restore staged main.py. Shouldn't change anything because it's basically the same. Yeah. And if I do git add main.py, and we're going to go do that, and we're going to do that. And once again, things are not staged, but the file still hasn't changed. So good to know that if we wanted to set things back or unstage things or undo our process to commit before we actually commit or push things, we can say, hey, just dump it all. Like, let's just restart our commit. So this is like canceling a save before you hit save. But you'll notice I keep saying, well, can't I just get rid of this? Can't I go back in time? Give me the last commit, which I'm trying to remember what it is. I think it's, there's a specific command, git reset to head. Okay. Okay, so if I go ahead and zoom in to Stack Overflow, necessary cookies only, I have Googled git reset hard head or git reset head because I want to reset my file. I want to remove my changes. So we're getting into the hard bit. This is my bonus a little bit, where if I say git reset hard head, it will go back to the commit based on that. But, let's see. As you can see from Stack Overflow, git reset hard is always a potentially dangerous command. It throws away all your committed changes or your uncommitted changes. So, because I do want to reset things, I do want to do that, I'm going to still do that. So instead of doing that, git reset hard head. Okay, voila, it's gone from the file. Okay, so if we ever wanted to just reset and go like, just go back to the last save, like it's so bad or something's wrong or we just want to restart, that's a good way to do it. I would not recommend doing this if you want to save your changes, which let's say we did. I'm going to show you git stash. So wonder if it'll come back. So if I hit undo, it came back. Nice. We're going to do git stash. Okay. So I stash things. Things are gone again. But it's not like I said, get rid of what just happened like I did with reset. The only reason I was able to bring back stuff was because I had the file open and I could hit undo. But if I don't do that and I went on to do something else, that'd be lost forever. Now, if I'm stashing things, maybe it's because I want to save something for later, which is what it's done. It's saved the working directory and index state to work in progress on the main branch, and it puts me back to the latest commit that I've made, which was my bug fix here, and the commit hash. Okay, let's say I want to get my stash back. Okay, well, git stash pop, I think. Okay, voila. Stash is a stack, so I can just pop things off, which means I can put a lot of things in my stash. If I really wanted to. I would not recommend that because then you start losing track of things. You can do a log or something like that on the stashes to see what's going on. Just try to minimize how much goes into the stash because then you got to have working memory, and I'm like, I don't have working memory. Okay, but now you can see, hey, it adds some things, and it removed the reference in stash. Now there's nothing else in there. It's an empty stack. We're good. Cool. We played a little bit with the hard things, but I haven't answered the question yet about, well, what about that that commit that's here that's not in my log? And Shenmarie totally got it. Don't you need to do a pull to get it to sync? And you're absolutely right. So this is where I'm going to break pull into two commands. We'll come back to that fun fact that I had mentioned. And that's how we introduce another medium thing. There's there's specifically something called git fetch. And git fetch is part of the git pull. So one way to understand this, and I don't want to do this yet because I want to prove the point. So if I do git fetch, okay, it's pulled some objects for me, but let's go and see, hey, my README isn't updated. When I fetch things, it will go fetch those changes. And if we go back to our GitHub, close that tab, we now have this history of commits that now is mimicked. If we were to do a git log, we would be able to see all these commits. We would we'd extra see this specific change. But what we have noticed though is that this does not match this. This is completely different because we haven't formally pulled those changes. So if you ever want to see, hey, how many commits am I off? How screwed am I? If you want to. That's a very extreme case. That's not actually the case. It might be that your friends have committed a lot of things and you need to start figuring out how you're going to merge that in. So it says that your branch is behind the main branch by one commit and can be fast forwarded. On a good day where no one's interfered with your stuff, you can just say git pull and you're good to go. It's awesome. You can also say git merge, but you may not want to do that just yet. So we're going to do git pull, where git pull is the combination of git fetch and git merge. That's what's actually going on behind the scenes. Super neat. I actually really enjoy that fun fact. But now we have our updated README, which has everything from that commit. Hooray. But what if we had added this line before we went and pulled things? Well, we would have maybe had a merge conflict. And that's a little less than ideal. So what if we want to jump back in time? What if I want to force a merge conflict? Well, let's go Google it. I want to go and jump back in time. So git jump back to previous commit. And this is how we're going to use hashes. Okay, so if I do git log, I will see everything we've done from top to bottom. where I don't want this commit in my local instance for whatever reason, because I'm bored like that. It happens. It's even more nerve-wracking for me because I'm doing it on purpose, and I'm like, am I good enough at it to do it on purpose? Because that's the ultimate way of whether or not you know things. If you can do it on purpose, that means you extra know how to fix it. If you can do it by mistake and kind of come back, you're still kind of getting the feel. You're in the intermediate. But I'm doing the advanced stuff that I'm like, I don't think I'm good enough to undo what I do. So I might break my project. But as you can see in the Stack Overflow, and the reason I'm purposely showing you these Stack Overflows is, one, I never remember all the commands, and two, you might be doing something like this too. So I want to make sure that you are able to do this on your own if you got into it. So they're talking about reverting a commit. So I wasn't sure the exact terminology. I was like, go back in time, go to previous commit. It's called revert. And so it says this depends a lot on what you mean by revert. So you could temporarily go back to it and then come back to where you are, where you check out the commit in a separate branch. This might leave you in a headless state. We're going to do that on purpose too, but not right now. On the other hand, though, if we wanted to, say, add more commits to it, then we could make a new branch. And this now starts to introduce this thing called checkout that I skipped over. We'll come back to that too. Okay. If you really want to get everything removed beforehand, remember that reset hard? Well, you can, instead of going to head, which is the most recent commit, you can jump back to commit hashes, which is exactly what we're going to do. We're going to go back a commit on purpose. And we're going to see if I create a merge conflict, because I'm kind of scared. I don't think this is going to work the way I want it to. Okay. So git reset hard. Previously, we said jump back to head to remove our local changes. We're not doing that this time. We are, however, going to this commit. Now you can see I've copied the whole thing. I don't really need to though. I don't remember the exact length. I think it's like 6 of them or something, but I can just copy the commit hash that I want from here because it's the most recent commit. And so let's go back to our commits, and I actually want this hash. Give me this hash. I don't want the full, I just want, why? Oh, let me see. I just want to copy. Yeah, this is that. Is this the right one? No, this is the previous one. Okay. Parent commit. Give me this one. I just want the short commit because I want to prove a point of how I used to do things, even though I was bad at it. But I never actually broke things. So maybe it's fine. All right. Git reset hard, and we want the commit hash 41760D6. Okay. And if we can now have gone back in time, we are in the same branch main, and we have gone back to our unmodified README. So let's go modify things. I didn't spell archive right. Hit save. Git pull. Break it. Break it. Hey, okay. So there's an error. We have our local changes to the following files that would be overwritten by the merge, where I spelled archive correctly. So it says, please commit your changes or stash them before you merge. And then it kind of just derped and left. So what happens is the git pull is canceled. So there's 2 options for me. I could make a commit, which I'm not going to do because this is a project I want to look nice. But you could play with this on your own to forcibly do this, where you just make a private repository that you're breaking on purpose. But what I am going to do is I'm going to stash them, because I do want to force a different scenario where I do want to force the merge conflict, but I don't want to force something called rebasing, which I think is what's going to happen if I make a commit. And I'm just not right now. Not right now. You can see that even though I'm a little bit nervous about it, because I'm like, I don't think I can come back from that and make a clean commit. But that's something that Google and ChatGPT and even asking people who are experienced in Git would help me. So we're going to stash, where I already taught you how to use stash. It put things in the working directory. I'm going to go ahead and pull. No conflicts whatsoever. And now we do a git stash pop. Okay. Now we have forced a merge conflict where it's saying, hey, I have this really lovely thing with Visual Studio Code where it gives me, I could resolve in a merge editor, I could accept the current change, I could accept the incoming changes, I could accept both, or I could compare changes. I want to compare them. So it says that it appears that I've deleted this whole, let me see this, please, thank you. It appears that I have changed this X, which is exactly what happened, but I've also added all of these things. And as you can see from this, it's not really clear that's actually what happened, because that's not what happened. What happened is nothing really got rewritten. I just added a bunch of stuff, although apparently this is being added. And also I only changed the X. So this isn't exactly the most intuitive, but you can see that it's telling me what the current changes are and what the incoming changes are. Which now it's important to figure out the order. So what was the order that things happened? First, I made a change to archive and capitalized the X. Next, I stashed the changes. Then I pulled the new changes down from that commit. And then I unstashed my change from the very beginning when I capitalized that X. So based on this order of operations, the current changes are actually the full README that I pulled back here. So when I unstashed it, the incoming change is that capitalized X, which is exactly what's happening if you now know the order in which things happened. Okay, so it's not that we want to delete all of this. We just want the capital X. And this is Git's downside. It's pretty smart at handling differences. But if it's a difference that happens in the same line as where a change is already happening, it flips out. It does not know what it's doing. It's like, Mom, please help. I can't do this. You fix it. This is too much for me. And that's okay. We want that to happen, because if this just slams stuff together or you force pulled or force pushed, woof, that would suck. Have you or a loved one been a victim of forced merges and forced pushes? Because I have. It's painful. It affects my project grades usually. Since it's a simple change, we could actually accept the current change, which is what this is. It's highlighted in green if we go back to the original preview. And it says, hey, this is what happened, which again, remembering that order, the thing that happened was we pulled the change and then we unstashed the other change. So based on order of operations, technically that README, that new commit, is actually our current change, and the stash pop is our incoming change. Order of operations is really important. I always forget it all the time. It freaks me out because I'm like, oh no, what do I do? Pause. Think about the order of operations. Figure out which one you want. Alternatively, hit undo and pray undo works, because sometimes it don't. Okay, so we have our current change, which tells us it's the README. And then we have our incoming change in blue, which, again, Visual Studio Code's super nice about this. If I wanted to personally edit this, I would have to delete this line on 22, 20, and then on line 2. I'd have to delete those for all the merge identifiers to stop freaking out and saying, you have a merge conflict. That would get rid of the merge conflict. This is one of the ways that I or my loved one has been hurt by merge, like force pushes, where if you don't resolve all of your merge conflicts, this garbage gets pushed into your file, which means your compiler breaks. You don't have a functioning project anymore. You have garbage. So, warning aside, what we do want to do is actually work with what they're giving us. We know exactly what's going on. It's a super easy fix. We're just going to accept the current change and call it good, because all you have to do is that. And then you hit save and you're good. And so you see that it's still kind of wigging out a bit, where it's saying, hey, the conflict has been modified, but like it's still screaming at you. So let's go back and do our trusty old git status. And now we want to add that file, because this is what happens when you make a merge conflict fix. Let's go ahead and check git status again, make sure it's good to go. If we really wanted to, we could just make a git commit -m fixed merge conflict with README. Again, being specific because, hey, we had a merge conflict with the README, but nothing else. Okay, now it's pushed, and now the file is happy. And if we go back to our git log, remembering that we haven't pushed anything, because I'm not going to, because I'm going to delete that commit, It's going to say now that our branch is ahead of main by 1 commit. And friendly reminder to go ahead and git push your local commits. There's nothing else to commit because our working tree is clean. Basically, there's no other edits in a file to save. So we're not going to do that though, because I don't want to push that to my GitHub repo. Let me leave that open just in case. All right. So we've talked about the previous head or even a previous commit. We've talked a little bit about merging. We haven't used it explicitly, but we have used it indirectly by using git pull. We've initialized a repo in words. We've worked with git reset and how dangerous it can be if you don't know where you're going or what it's going to get rid of if you don't use it correctly. Okay. We really haven't talked about these, though. These are the ones where you are the guru fixing the people who don't really know what Git's doing. If you're not familiar with Git, you'll find that people are mentioning these things to you, and you're like, I have no idea what that is, but it sure is magic. You are a wizard. Because it's kind of hard to understand sometimes. Let me make sure we did everything. Yes, we did. We did these. We did. Oh, we're doing great on time. We've got like 20 more minutes. Fantastic. Breaking things all the time is a great way to learn. Case in point, I've never purposely forced a merge conflict like that and actually had it been successful until today. I work with a lot of merge conflicts whenever I've been in industry, and also when I'm working with team members or like hackathons or like my student projects. So do you still feel nervous? Because we survived. we did it, folks. Okay. It is extremely warm in my office because it was very hot today. We got to 104 and my office is horrible. Okay, so I do want to do a quick pause and ask for like questions, comments, concerns before we get into the hard stuff. Because this will be conceptual because I don't know how to mimic these, but it's good to be aware of what these are. So that way, you're prepared for if it happens and you're like, oh, yes, this is what I should do. Now I can go Google it and figure out what I need to do and make an educated guess instead of like, I think this is the thing I need to do. I'm going to pause, give a bit for any questions. My Git wizardry is not as good as some friends of mine, but one day I hope to be at that point. But I had to use these things and they told me do the thing and I'm like, I don't want to do the thing. Their wizardry was too much for me. In the meantime, I'm going to go Google how to delete a commit. Git delete commit. Local. Git undo. I'm going to go do git undo because that seems appropriate. Git undo. Undo is not a git command. Oh, I should have read that. I am plagued by my own preaching. I should have read that this didn't exist. Alrighty. There doesn't really seem to be any questions yet. So let's go ahead and start talking about a couple things. Something I just used was git reflog. I actually recently learned about this, but this is like a more intense git log that lets you really go through and see what you've done. And so what that means is you can see, going again in reverse, I made the commit where I fixed the merge conflict. I had my pull where I fast forwarded that README file. I moved to the head. I moved to a previous commit. I moved to the head. I pulled fast forward. And this is around, I think, where I had that merge conflict that I didn't want to do, so I jumped back. That's what was going on here. Okay. I had my various git reset commands, good to know, where I was fumbling around figuring out how to remember to reset the file itself and not just the stage stuff. And then I have my commit messages, my pulls, reset, commit, initial pulls, etc. So, neat. That's the end of my history. For a much bigger project, that's going to be massive. However, if you ever want to undo what you just did, this is the extra dangerous part. In that, as long as you know what it is you did, you might be able to recover your stuff. I don't have that skill yet, given that I learned about reflog like 2 weeks ago. And I was like, I had no idea that was a thing. And that was the first thing I asked with regards to the person at Sunhacks who, unfortunately, they lost all of their stuff. And I said, well, did you use Git reflog to try and get it back? Apparently, even with that, they couldn't get it back. So your mileage may vary as far as any mistakes that are really breaking that you do. But here's another way you might be able to recover anything you may have goofed on, presuming you have the knowledge or someone near you to babysit you while you panic about what you're doing. Okay, so we talked about reflog. Let's talk about headless branches because I really hate them. Let me tell you a story about headless branches, I guess. Once upon a time ago, in one of my past degrees, I was on a group project. I had the ultimate faith that the people I was in the group with, because I had chosen them, were exceptionally good, or at least competent at Git, enough that I would not have to deal with strange issues like force pushing. I did, in fact, have to deal with that because the professor said, hey, everyone has a project folder on the same repository. Everyone just needs to push their folder. You can imagine how that went, and it was absolutely terrible. But it was a very interesting lesson in how people will still mess up GitHub. Because they did. Anyway, merge conflicts that one introduced, because that was really frustrating. Headless branches are something that can accidentally happen if you're not really sure what you're doing. And it happens when you check out a temporary commit, which I've said we would come back to, so here we are. You'll see that it says git checkout and then the commit hash. When you've detached your head, that means you've it's like the magic trick where you have like your thumb and you're showing people and you're like, oh, I separated my thumb. That's basically what happens, except you legitimately are separating and delete any, there is no main to connect to. There is no connecting part anymore. Once you've separated it, that's it. So that's not so good, because what happens when you make a commit and then you try to, make a branch out of it? Well, the answer is you have a completely disconnected branch that doesn't know where to go or how to do diffs because it can't reference anything. And that is called a headless branch. So let's do it on purpose. I did pull up a tutorial for this because I didn't know what I was doing, and I wanted to. Where is it? Okay. Let's make a detached head because this one makes me scream. Okay. Zoom in a bit. So in this instance, they make a folder called git head demo. They've changed into it. They've initialized the folder as a Git repository. They've created a file. They've committed the file, and then they added some stuff to the file. And then they added a secondary commit where they added the line to the file. They did some other stuff, committed, whatever. Point is, they've created a Git history of a couple changes or a couple commits in a file. Fantastic. Okay. Apparently you can use git log one line. Neat! I had no idea. The more you know. Keep going out. Okay, so we've made commits. Even though they're local, they're going to have a hash. So if we want to check them out, we would run git checkout a specific hash. So once you've run the command, you get you are in a detached head state. So in order to do that, you check out a hash. You can also check out a branch. So what I didn't tell you is, hey, right now in this, we're on the main branch. Let me zoom in some more. Right now we're on the main branch. I want to change branches. We're going to say -b, and you'll notice I'm saying git checkout -b. I'm going to name it alt branch for giggles. And now I have switched to a new branch called alt branch. If I do git branch, I will get a list of what branches I have locally. If we go to GitHub, I can pull it up, you'll probably see that there's no branch of which I am referring to that. Because, as always, I haven't synced. I haven't pushed my stuff in that branch. Okay, so if I want to no longer, let's say I want to go back to the main branch, I would just say git checkout main, because main already exists. If I want to create a branch, the shortcut is git checkout -b, and then whatever your branch name is. There's another way to do it where you can say git branch and then a couple other things, but to be honest, if I create a new branch, I immediately want to go to that branch. So I never use this command git branch. That's just me. But if I want to delete the branch, I think it's -d alt branch, and I need to make sure I'm not on the branch that I am deleting, because that would be awkward, and it's just a good habit to have, because what happens if you accidentally delete the wrong branch somehow? Okay, something that I didn't show you though with git branches is, well, if there's no branch on the remote repository and I make a commit, remember, this branch is still connected to main. We haven't done this little magic trick with the thumb, right? We haven't entered a detached head state because we never used a commit hash. And I'll show you really quick how to do that. Let's go back here. Let's see if it will let me do this. Okay. It's telling me I'm in a detached head state. I can look around, make changes, commit them, discard commits, and switch back to a branch. But there's a way to cause issues if you don't properly do things. So currently this is at the commit that I went back in, and it's telling me I'm in that branch that I've checked out for that commit. I would recommend you don't turn off this advice, because the moment you have a detached head, Lord. Okay, continuing story time. Again, I was on a team. I felt the majority of people were quite competent at Git, and therefore I was the weakest link and I was likely to cause issues. That was not the case. We had someone who had only ever really used GitHub's UI. And that's not necessarily a bad thing, but it certainly impacted them negatively, because when they did come to doing CLI stuff, they struggled. It was extremely uncomfortable for them to use it. And as a result, they didn't realize when they had entered a detached head state, which meant when they tried to merge their branches, it didn't happen because it's a detached head state. So you need to reconnect things, which means you need to do other work. But they had no idea how to do that because their GUI didn't do it properly that they were using. I can't remember what it was, but it's certainly not in my list. And they themselves didn't have an understanding deep enough to fix what they'd caused. It's very easy to jump into this if you don't know what you're doing, because you might be like, oh, well, I know hashes are important. I want to go back in time. And then maybe they forget about it, which I've forgotten, and I've been on the wrong branch all the time. It would not hurt to learn how to move your commits across branches. So that's a fun homework assignment. But I don't actually care to be there. I don't need it. Git checkout main. Great. We're back to normal. Things are fine. So this person entered a detached head state, made commits, and then tried to merge their branch into main using a PR. And somehow, I think either the PR went through, it's been a while, so I can't remember exactly, or they tried to merge the branch through command line, which you can technically do if the permissions aren't set correctly, but you will always have a detached head state if so. And let's say they've pushed the branch somehow, and I mistakenly check out that branch. Now I'm still working on a detached head state. Now things get very messy and gross. Not fun. So be mindful of what branch you're on when you start switching branches around. And some tips to consider with regards to development is when to use branches. And it depends on the industry, depends on the group, depends on the class. The short version is a branch should make sense. Something good to keep in mind for any and all hackathons, and generally any project that you do, is that your main branch should always be functional, which means your code always works. As long as you work with branches, let's say I decided I wanted to keep working on my archive notifier. I would maybe create a feature branch, and I would call it something like param feature. And that's how I would maybe add the feature to let people put in custom parameters to this script instead of having to change it on the script itself. And so I do the work on this on a separate branch, make the commits on that branch, and then open a pull request, which would allow people to look at my code and tell me, yep, that looks great, or you forgot some comments, or I'm not sure what this is doing, or maybe I'm doing it for a task, in which case I might do a specific issue number, particularly if it's a larger project. So it might even actually instead be issue-based branches, where instead it would be issue dash whatever the number is, if it's that many issues or that. And then I would describe it and say something like params, something descriptive, so that way I know what branch it is, because honestly, if I'm a developer in industry, there might be a lot of issues I'm working with. So we have feature branches and issue branches. What are other kinds of branches? There could be just developer branches, where maybe you have dev. Everybody merges their stuff to dev before it merges to main. So now we have a two-stage way of checking if your code actually works before it ever makes it to main, presuming main is locked down. As long as you've restricted the permissions on main, it might be that no one can push or merge to main. Great idea, highly recommend. However, if the people reviewing your pull requests don't actually care to check your code, that's how you break main, and then you have to go back and fix it, and then you have to wait for reviews, and then it gets lengthy. So another way that people do it is that they'll make a dev branch that all other developers with their feature or issue branches would merge into first. Then at the end of a sprint, for example, it might even be that this is just sprint 1 branch. Everybody merges this into sprint 1, and then they test everything at the end and then merge that into the main branch. So that way there again is always a functional project on the main branch. This is a style of agile methodologies, which if you're into software engineering or you have familiarity with it, this is one of the ways that they do it, which is why feature and issue branches exist. You could also do literally a developer branch, where maybe it's Cecilia's branch. That exists. It does happen. I haven't personally worked at a company that does that, but I have sure as heck seen it. So it depends. It might be that that's where I do all my work, and that's how I merge it into the dev branch or main branch or whatever. Now, what happens when I have an issue branch that when it's done, I no longer get to? So coming back to that, if I have an issue branch, probably once the PR is done, well, the branch is closed. And so it might just go stale, which means there's no changes to it. And eventually someone goes through and cleans up stale branches. Or you might have an automated extension or something like that. I forget exactly the name, that will clean up stale branches for you. And so when you're doing issue or feature-based branches, this is pretty common. It's good to just delete your branches when you're done, because that thing is done. And if you have to do any bug fixes or other fixes, you might open a separate branch off of where it was merged into. So you might branch off of, say, dev and say issue 574 fix or something else. There are many ways to use branches. Figure out which works for you. It might just be that because you're a lone developer, you only really work on main. But if you're testing something out or doing something big, you might have your own dev branches that do different things. Pick what works for you. Don't forget the -b though, because that's what says create a new branch when we're checking it out, because otherwise it'll be like, well, what do you want to move to? What branches do you want to switch to? Cool. So let's go back to our list. We have finally talked about branch, and we've also talked about branch. I personally don't use it. Go look at the docs. We did all that. We've done all that. Hooray. We talked about headless branching and reflog. We did skip one that I'm trying to remember what it is that we skipped. We didn't talk about forking. So I told you about clone, where if I go back to my notifier and I want to clone my project, I would just say, hey, go to the code, clone it, good to go, copy that URL to clipboard. Because I have editing permissions because it's my project, I can push this whenever I want. But what if it's an open source project that's like, no, don't do that. We don't do that here. Well, more specifically, what they're saying is if it's an open source project and you want to make changes, but you want to have your own local instance that you work with, or maybe you like a project and you want to keep doing your own thing with it, you might consider forking it. Forking is a variation of cloning where you create the repository in your own profile. So you'll see up here, it has my username for GitHub, and then it has my project name. Let's say you have a different username, of course, and you wanted to fork this project. And because you wanted to do your own variations to it, and maybe eventually you might want to say, hey, I found a better way to do something in your code because it was inefficient or whatever your reasoning is. And you want me to merge your code into my code. In order to do that, because I haven't given you edit permissions, I do allow you to fork your own copy. And so instead of being called Halcyon Aura Archive Notifier, it would be your GitHub name / archive notifier. Then you do your changes or whatever, you push them, and then it might say, hey, maybe you want to make a pull request. And so there's two types of pull requests that you can now do. You can do a pull request for your local instance, your name / archive notifier, or to bring code back to my repository as the repository you forked it from. So when it like really deviates, think of it like a fork in the road. You want to send your code to me so that I can consider if I'm going to include it, which is how most of open source works these days, where you fork a repository, you make your changes, and you say, hey, there's a pull request. I want you to add my code. Please review it. In which case, you would open a new pull request and you would send it to my repository instead of your own. And so there are ways that it might pop up here to show you how to do that. But that is what forking is. There's no command line instance with that I'm aware of, but GitHub makes it pretty easy to do that. And so right now it says I don't have a fork of this repository, which clearly means I can have multiple forks of this repository, which is quite dangerous. But yes, alrighty. So we have now officially covered everything from easy and medium. Hooray. We've got about 5 minutes. And I really didn't talk about rebasing, cherry picking, or patching. Rebasing is the more intense merging that I don't really know how to explain very well. But my understanding of rebasing is, remember when it said it fast-forwarded commits? Let's say you have 10 commits in a branch that you're merging into dev. And you say, well, I want to rebase it. Rebasing is a way of slowly hitting play and going through each commit to manually handle all of your expected merge conflicts. That's the best conceptual way I can explain it, where let's say you and your friend have each done 5 to 10 commits on your own feature branches, and there's a lot of intersecting points that you're fully expecting there to be merge conflicts on. Let's say your friend merges their stuff into dev, no problem, because they're the only person who was committed recently and there's no merge conflicts. You're finally done with your work and you're about to merge in and you're like, hey, I see you've edited in some files that I touched too. I don't want to have to go through each and every merge conflict and just keep saying, okay, git merge and git merge and git merge. I want instead like 1 or 2 commits. If you do rebasing, you can play the commits on top of each other between the two of you to see what merge conflicts you need to fix at each stage. So basically, you're taking over the diff process that Git does for you. So it might be that you're like, oh, yeah, some files, easy peasy, fast forward through those, but there's some files that it will get caught on and you want to handle those. Or again, you want to step by step make sure everything's good as you go 1 commit at a time, because it just so happens that they might be interlocking or, slightly shifted or something else. There's a lot of different combinations, but the point is you want complete control of what's going on. Rebasing is really important, particularly when you haven't pulled frequently from a very active code base. Chances are you'll need to rebase a lot. And if you're not careful, you make some really janky commit messages, so I highly recommend taking the time to practice, because that's something even I should do. I'm not the best at rebasing. I always mess it up. Then you have a small subset of that called cherry picking. So rebasing is playing things on top of each other. Cherry picking is saying, I want this one, that one, but definitely not this, this, this. So cherry picking lets you pick certain commits that you want to put into a new branch or a pull request or anything else. And so maybe you have a feature branch and it's full of bugs, but you know that there are certain commits that are solid and good to go, and you want those reviewed elsewhere. And so you might create a new branch that's cherry picked from the specific commits that you know are going to work. Thereby, you don't need to have to merge the whole janky branch of all the messy, nasty commits of things that you tried. It's nice for history purposes, but some people really like clean branches and commits. So as a result, they'll cherry pick the things that they know are like, yep, this is good, or good, pull it out, make that branch, and that's what they actually merge in the end. Varies from person to person. There are other ways to use cherry picking. It's often actually a way to deal with reversions. So for another example, what happens if you have a code base where someone just keeps force pushing and you're like, bruh, no, stop. This is not working. You're not listening. We can't restrict you from pushing, but you keep messing it up. So you have to revert back on certain commits cherry pick the ones that worked, and then overwrite that history, which is exactly what happened very recently. It's very frustrating to have to do that repeatedly. But that's a way to mitigate, particularly when you have someone who doesn't know how to use Git properly and doesn't want to listen. There are other instances where it's also useful, again, making better timeline branches, etc. But that's the more real case that's going to happen, is that you're going to have someone doing stuff that doesn't make sense, and you're like, all right, let's go pick out the good stuff and get rid of the rest. Alrighty, let's talk about patches. Back when I learned about them, I was like, I don't understand. These are magical. I have no idea what's going on. But we had to patch things when we did have those people mess up the GitHub projects that I was working on, where we had the people with the detached head state, or people who overwrote entire files and therefore lost our complete Git history. That was lovely. Patching is a way to ensure that code ownership ends up in the right place. And that's the way it was used for me. It can do more than that, though. So this is very use case specific. But in my case, we had someone who used GitLab. That was where our project was hosted. Really interesting experience. There are major UI differences between GitHub, GitLab, and anything else you use. So if you're a UI user, what you do in GitHub is not going to be the same in GitLab, and it's not going to be the same elsewhere. So be extremely mindful of what doing one thing to one might do for another place. So the example that I'm referring to here is GitHub. You can upload the same file, and if there are changes, it will find those diffs for you and naturally merge it together. And if there's merge conflicts, you'll have to fix that. GitLab at the time, I don't know if this has been fixed, doesn't do that. If you upload a file with the same name, it will treat that file as a brand new file, which means your entire commit history is erased. So how do you go back and fix that? Well, with patches. The way that this worked, my friend realized what had happened. And because he had the history, because he pulled recently, but he hadn't pulled a new file, he was able to recreate patches of each of the code contributions that everybody on my team had made. And he sent us those patches with those commit hashes for us to implement, in order to ensure that the commits that we made, assured that we had authorship of the code that we had submitted, because it was important for a project that we needed to do. But the thing is, we had to do it in a specific order, and that was just to rewrite history, which is why, Git is a time machine. And if you don't know what you're doing, it's bad. But if you do know what you're doing, you are magical. And so what ended up happening is I had a patch, another team member had a patch, another team member had a patch, another team member, anyone who had worked on that one specific file, we did patches. And so it went in order of, okay, you make this patch, you do this patch, you do this patch, you do this patch. And each of our patches had those diffs of changes we had made to the code to rewrite our contribution history. Wild, but also extremely helpful in that very specific instance. So I did pull up Git patch because I did want to have a better, a better explanation that was more than just what I had gone through. The short version is they're basically just diffs. They're small pieces of code that are added on top of already existing code files to fix any issues. They could be bug fixes, vulnerability fixes, performance fixes, etc. So in this case, they're talking about Drupal. We're skipping that bit. But something I haven't told you about is git diff, which will show you all the modified changes that are not added to Git or staged. And as you remember from Visual Studio Code, it showed us things in blue or red. In the case of Git bash, it will show us things in green or red, where the things that are being changed are going to be shown in red with a minus sign in front, as you can see from this image. Anything that's being changed positively by adding things to it is going to be shown in green. And so you'll be able to see all of the different descriptions with regards to the commits, particularly if you wanted to see things. If you're looking at a specific file, which is the case in which I had to deal with this patch stuff back when I was an undergrad with my friends, we specifically diffed the file name, and we looked at all these different things that changed. And if you give it to a branch, you'll actually put all of those diffs in a separate branch. So there's a couple ways you can do it, and it goes through this whole process of explaining all these different ways you can see changes, do things, whatever. Let's skip ahead to where it's git patching with a git diff, which is exactly what we did. What they're doing is they're outputting those diffs to a patch. And that's why I keep saying a patch is a diff. It's the changes that occurred from one commit to another in a specific file, or files plural. But ideally, we're using it to again rewrite history in some cases, or at least assure that some things go through, which is why the patches that were created by my friend had to be done by each of us individually in a specific order. One friend did a certain commit in another place of the file, and once he did his patch, then I could do mine because I had additional things that had changed after him. Again, we rewrote history in order of what we had committed. So once you've created the diff, you haven't really done anything with it except made the patch file itself, or again, output the diff to a patch file. The next thing you're supposed to do is apply the patch to that specific file. So you'll just say git apply patch. And what it will do is tell you more about what's going on as long as you've used the verbose option, which I highly recommend, where it will tell you, hey, we're checking it, hey, we're applying it, here's what it's done and changed. And there are other things you should consider, such as whitespace, etc., and checking the patch, because you want to make sure that things are applied cleanly. And so we each had to do that again, with this project that I'm mentioning. We each had to check that the patch would work without merge conflicts, without other issues, without any warnings, etc. Because if we patched it and it was still broken, it would affect all the future patches onward. So yeah, really important that you always create a new branch when you're doing patching to rebuild history in a completely separate branch so you don't mess up the existing history. And let's say you only wanted to add things, then you can also change it with different features. So this is actually a really nice thing where you just are like, how do I do git patch? And there are ways that you can, again, limit it using different parameters. Super useful. All that to say, git patch saves your history, saves your life. Chances are, though, you're not really going to need it. Unless you're working with a team that may not have the best knowledge of Git and may use the UI to cause irreparable harm and awful things without meaning to. But there might be other instances that you run into it, and it seems like you're making them quite a bit. I'm kind of wondering what you're doing that ends up having to need patches in the first place, because I've only heard about it with regards to writing history. But we are at the end, so if you don't mind explaining about that one, because I'm curious, because I've only used patches to rewrite history. But if there's any other questions, we have a couple minutes left. You're making patches to your own repos. I hadn't really ever considered that, but based on the fact that you're just applying diffs and changes, I think it's kind of the same as cherry picking. I'm not sure. I'm going to have to Google that and see. With changes. Yeah, well, the changes themselves are diffs. I don't know. Let's Google it. Well, let's see. Make pat git patch. Why use? Okay. Patches are used to share changes between repositories without committing or pushing changes directly to a remote repository. Interesting. A patch is a text file whose content. Let me zoom in a bit as well. I realize I'm not zoomed in much. A patch is a text file whose contents are similar to a git diff, but with the code it contains with metadata about commits. Which, if you're rewriting history, yeah. Patch files are unified diffs, whereas a pull request is a request to an owner. When to use git patch? Sharing changes between repositories without committing or pushing changes. Neat. I'm honestly not really sure. I wonder what's going on there. I will think about that. And if you're at Career Week and I'm at Career Week next month, maybe I will have some answers. Because by that point, I should be freed up in a little bit of some brain cells, hopefully. I want to look into this because I want to learn more about patches, but I'm also like, I wonder why you've got patches. How to generate. I mean, if you're like doing things such that it doesn't end up in a remote repository, perhaps, which I don't know why you would do that, but I wonder if there's a setting or something else going wrong there. Alrighty. Like I said, we are at the end, so I want to make sure that if there's any questions, make sure you drop them in chat. If not, we'll basically wrap up and we're almost done. So let's go see what's coming up next while I wait for anyone to drop in chat some ideas or some questions. Schedule. All right. So in about an hour and 5 minutes, you will be with Alberto, actually, who will be teaching you about how to improve your open source project. And then there's going to be another very early morning for me. Heck no. Another early morning open source mobile project part 4. I do believe this is the last part. I know Kari's super excited with getting you all going on this. And then it seems like we'll be wrapping up with Ryan's project and going into closing ceremony. So if you have any questions about Career Week, that's a great time to ask at tomorrow's closing ceremony. But otherwise, thanks so much for joining. I have talked your ear off about Git and learned plenty of things in the process, actually. It was stuff I needed to learn anyway. Oh yeah, it's totally Vim. Absolutely Vim. It might be depending on if you're using it correctly or not, because unforeseen issues when you're doing commands that you don't really know. But I also don't think it's Vim. Who knows? But cool. Thanks so much, everyone, for joining. I hope you learned lots of new things and feel a little more comfortable about seeing new things in Git, because I've basically exposed you to most of the things you will see in Git. If you're doing anything more than that, maybe you should be teaching me. Okay. Giving it just a few more seconds in case there's anything left. But it is just about time for dinner for me, and I'm very excited to go eat. Oh, you're very welcome, folks. I'm really glad I could help you all out. I really do hope it helped. Me too. My prep work is always like, what is this? Have I done this? Oh, yeah, that's a memory I blocked. Awesome. I'll let you all go. Take a break for an hour if you plan on joining the stream later today with Alberto. Highly recommend. But otherwise, get some good rest, water, and food. Bye, y'all.